Hi there. Welcome to this lesson on Pure Mathematics 3. We're on Chapter 3, Trigonometric Functions, and in this lesson we're looking at solving trigonometric identities that involve sec, cosec, and cot. We did look at these in an earlier lesson, but they're slightly harder questions today. Now, we've already met the following identities. Sec is identical to 1 over cos. Just a reminder, those three lines there, they're what you use if you're being strict and formal. It means that sec x is absolutely identical to 1 over cos x. It's not that it's true for some value or values of x, it's always true. In that case, it's good to use three lines. It means identically equal to, exactly the same as, always. Cosec is the same as 1 over sine, cot is the same as 1 over tan is the same as sine over cos, cot is the same thing upside down, cos over sine, and sine squared plus cos squared always equals 1. Now we need to meet two new identities today, and we'll look at sine squared and cos squared and adapt that. First of all, we adapt it by dividing through by cos squared x. If we do that, we'll get sine squared over cos squared, because cos squared over cos squared is the same as 1 over cos squared. These all simplify. Sine squared over cos squared is the same thing as tan squared. The cos squareds cancel to give us 1. 1 over cos squared is the same as sec squared. It's normally written the other way around, but it doesn't matter. So 1 plus tan squared x is identical to sec squared x. We'll then do the same thing again, this time by dividing through by sine squared x. That'll give us sine squared over sine squared plus cos squared divided by sine squared is the same as 1 divided by sine squared. The sine squareds cancel to give us 1. Cos squared over sine squared is the same as cot squared, and 1 divided by sine squared is the same as cosec squared. So that gives us two new identities. 1 plus tan squared is sec squared, 1 plus cot squared equals cosec squared, and we'll add those to the ones we already knew. Now you do need to know all of these, and you'll need to use them in this lesson. So if you're not familiar with them, I'd pause the video at this point and quickly write them all down. Okay, first example. Prove the identity 1 plus sine theta divided by 1 minus sine theta is identical to sec theta plus tan theta squared. When you're proving an identity, you do have a choice to make. You have many choices actually, but the first one is to either start with the left-hand side, change it, adapt it, try and prove that it equals the right-hand side, or start with the right-hand side and try and prove that it equals the left-hand side. On some questions, it's definitely easier if you do it one way rather than the other. On this particular question, I think it's equally easy or equally hard both ways. Now, what I'm going to do is choose to start with the left-hand side by multiplying it by 1 plus sine theta over 1 plus sine theta, which means I'm just multiplying by 1, so there's no problem there. If you want to be able to follow through your answer with me, I suggest you do the same thing. Anyway, pause the video, have a go yourself, come back when you're ready. Okay. I said what I was going to do was multiply by 1 plus sine theta over 1 plus sine theta. That may feel a little bit random, but it's not as random as it looks. If you look on the bottom of the fraction, we have 1 minus sine theta. If we multiply by 1 plus sine theta, that'll give us the difference of 2 squares on the denominator of the fraction. That is frequently a very useful thing to do. It's frequently useful with this type of question. It's also useful when you're working with surds. It is also useful when you're working with complex numbers. And there are a number of situations where if you can create the difference of 2 squares on the bottom, on the denominator, it just helps move things forward in a positive way. So that's the reason for doing it. Now, if we multiply that out, on the top, we'll get 1 plus 2 sine theta plus sine squared theta. And on the bottom, we get the difference of 2 squares. It's 1 squared minus sine squared. Now 1 squared is just equal to 1. The reason why this is a useful thing to do in this question is we have an identity. 1 minus sine squared, that's identical to cos squared. So we can change the denominator to cos squared theta. Having done that, it's now easy to divide out the fraction. So we'll get 1 divided by cos squared, that's sec squared theta. The middle term's the confusing one here. 2 sine theta divided by cos squared theta, well, the 2 just stays as 2. Sine over cos is tan, and that will leave us with 1 over cos to multiply by. The third term is just sine squared divided by cos squared, which is tan squared theta. 1 over cos theta, that then simplifies to sec theta. Now, all the time we've been doing this, we should have been keeping an eye on the right-hand side of the original identity. We started with the left-hand side, but what we're trying to do is to change it so that it looks exactly the same as the right-hand side. So the right-hand side is our goal. That's what we're trying to get to. Now, if I square that bracket, sec theta plus tan theta, I get what I've just written down. That means I've succeeded. That expression there that we got to is identical to the right-hand side, sec theta plus tan theta all squared. So I've started with the left-hand side, and I have shown that it is identical to the right-hand side. At this point, you could just restate the question and say, therefore, 1 plus sine theta divided by 1 minus sine theta is identical to sec theta plus tan theta all squared. Or you could just say QED. QED is a common way for finishing this type of question. It comes from the Latin quod et demonstrandum, and it means I've demonstrated what you asked me to demonstrate. Okay, example 2. Now, example 2 is the same question, but just to prove the point we were saying beforehand, which is you could start with the left-hand side, or you could start with the right-hand side. This time through, we'll start with the right-hand side of the identity. And what I'll do to it is I'll immediately change the sec theta to 1 over cos theta and the tan theta to sine over cos. That again is frequently a useful thing, to change things to sines and coses when you can do. It doesn't always work, but sometimes it's a helpful thing to do. Anyway, pause the video, have a go yourself, come back when you're ready. Okay, we'll look at this together. So I've converted the right-hand side as I said I would. We've got 1 over cos plus sine over cos all squared. Now you've got cos theta on the bottom of both these fractions, so you can just join them together into 1 plus sine theta divided by cos theta. Now the next step isn't immediately obvious, but what I will do is I'll square the bottom to get cos squared. I won't actually do anything with the numerator, with the top of the fraction. I'll just leave it as it is. Now the reason for that will become clear later on, but it isn't obvious at this point that it's best to do it. Cos squared theta, well, I can use the identity that cos squared is the same as 1 minus sine squared theta, so that might be a helpful thing to do. And then 1 minus sine squared, like on the last example, that's the difference of 2 squares. So I can write that as 1 minus sine theta times 1 plus sine theta. And the top I'll break into 2 parts as well. Now it is only at this point that it becomes clear that this was a fruitful approach to this identity. Because at this point I can cancel the 2 1 plus sine thetas. That'll leave me with 1 plus sine theta divided by 1 minus sine theta. And that is what I wanted to get. That's the left-hand side of the identity that I was trying to get. I think one thing that this demonstrates is with identities, when you start the question, it is not always obvious what you need to do. You have to be willing to try something, to experiment, see if it works. The more of these questions that you do, the more practice you get, the more you'll become familiar with the type of things that do frequently work. But still, it'll be often the case that you'll try something and it won't work. You need then just to go back to the question, try something else and see if that works. But in this case, this is the right approach. The 1 plus sine thetas cancel. That leaves me with 1 plus sine theta over 1 minus sine theta. And that is the left-hand side of the identity. So I started with the right-hand side. I've proved that it's the same with the left-hand side. I have done what they asked me to do, QED. The question is finished. Okay, and that gets us to the end of this lesson. If you have the textbook, turn to page 60. Have a go at exercise 3D. And questions 6, 1, and 10 to 12 are on those types of question. Thank you very much for listening, and cheerio.